Good afternoon, student. Today we are going to see the syllabus of MSc second year, same fourth. Let's start. Paper 1 Spectroscopy second. Unit 1 Raman spectroscopy. Classical and quantum theories of Raman effects, normal resonance, and laser Raman spectroscopies. Pure rotational and vibrational rotation Raman spectra. Selection rules. Mutual exclusion Raman spectroscopy. Coherent antistrokes Raman spectroscopy. Application for the study of active sites of metalloproteins. Structure determination by symmetry selection rule, that is normal coordinate analysis. Rotational Raman spectra. Vibrational Raman spectra. Polarization of light and Raman effect. Structure elucidation from combined Raman and IR spectroscopy. Applications in structure elucidation. Application of Raman spectroscopy to structural chemistry. Second, B. Photoelectron spectroscopy. Basic principle classification of electron microscopy method photoelectric effect ionization process Coop- Koopman's theorem PES and XPES PES spectra of simple molecule ESCA chemical information of ESCA agar electron spectroscopy basic idea scanning electron microscopy working of SEM instrument surface characterization by spectroscopy and microscopy atomic atomic force microscopy application AFM comparison of electron microscopy with electron inversion photoemission multi photo ionization spin resolve photoionization. This is all about unit 1. Second, unit second, X-ray diffraction, interaction of X-ray with matter, scattering and diffraction. Bragg's method, Debye Scherer method of X-ray structural analysis of crystals, index reflections, identification of unit cell from systematic absence in diffraction pattern structure of simple lattice and X-ray intensity structure factors. Its relation to intensity of electron density procedure from X-ray structure analysis. B part electron diffraction, scattering intensity versus scattering angle, viral equation, measurement technique, elucidation of structure of simple gas phase molecule, low energy electron diffraction and structure of surface. C. Neutron diffraction, scattering of neutron by solid and liquids, magnetic scattering, measurement technique, elucidation of structure of magnetical order unit cell. Next, unit 3. Electron spin resonance spectroscopy. Introduction. Basic principle, zero field splitting and Karmal degeneracy. Factors affecting the G value, hyperfine splitting, hyperfine and super hyperfine coupling constant, determination of G value, instrumentation, working of instruments, sensitivity, concentration, choice of solvent, presentation of ESR spectra, application of ESR to study the free radicals, structure determination, reaction velocities, Mach-Connell relation, application to inorganic compounds, including biological systems and to inorganic free radicals, such as pH4, F2, BH3, determination of oxidation state of metals, Eldor and Eldor techniques, the EPR of triple state, structural applications to transition metal complexes, ESR spectrum, when one electron is influenced by a single proton and one electron delocalized over two equivalent protons, difference between ESR and NMR. Unit 4th. Mossbauer spectroscopy. Basic principle, spectral parameter and spectrum display, Doppler shift, recoilless emission of radiation, the Mossbauer effect, isomer shift, quadrupole splitting, nuclear quadrupole moment, and EFG tensor, quadrupole coupling constant, and asymmetrical parameter, magnetic hyperfine splitting, applications of the technique to the study of bonding and structure of Fe plus 2, Fe3 plus compounds, including those of intermediate spin, SN2 plus and SN4 plus compound. Nature of ML bond, coordination number, structure and detection of oxygen state, and, and in equivalent MB atoms. Elucidation of structure I2Br2Cl4, I2Cl6, structural problem, Mossbauer spectroscopy of biological system, pure NQR and Zeeman spectra of spin 1 and spin 3 by 2 system. The Towner Dyle theory and interpretation of NQCC in terms of bond characteristic. NCC as 57 Fe spectra of complexes, other Mossbauer nuclei applications. Unit 5. Determination of structure of complex organic molecules by spectroscopic means problems based on IR, mass, UV, PMR, 1H, NMR, 13C NMR data, and structure determination of organic molecules, inorganic compounds. This is paper 1 spectroscopy. Next, second paper, General Analytical Chemistry. Unit 1, Radiochemical Method of Analysis. A part, Radiation Detection and Measurement. Principle and working of ionization chemicals. Multiplicative ion collection. Reasons of multiplicative operation. Proportion, proportional counter and Geiger-Mulker counter. Principle and working of scintillation counter. Semiconductor detector. Gamma rays spectrometer. Second, neutron activation analysis. Principle and methodology of neutron activation analysis. Application of neutron activation analysis in following branches of science. First, material science, geochemistry, archaeology, life science, biomedical science, food and nutrition, environmental science, forensic science, cosmochemistry, advantages of neutron activation analysis, sources of error, and limitations of neutron activation analysis. Isotopic dilution analysis. Principle and method of isotope dilution analysis. Sub Subgeometric IDA. Comparison of IDA with NAA. Application of IDA for the measurement of trace qualitative of organic and inorganic components in a given complex mixture. Sources of error and limitations of IDA. IDA means isotopic dilution analysis. Radiometric titration. Principle and method of radiometric titration, types of radiometric titration, applications of radiometric titration, source of error and limitations of radiometric titration, radioactive traces, principles and application. Unit 2nd, molecular photofluorescence and phosphorescence spectroscopy. Spectrometry. Basic theory instruments different photonic and deactivation processes, that is, interval conversion, vibration, relaxation, intersystem crossing inflorescence, phosphorescence, external conversion, etc. Their interrelationship and differences. Energy level diagram, Morse curve, principal type of electronic transition, principal type of linkage in fluorometric reagents, reagents effects of substitution upon photoluminescence, structural and environmental effects on photoluminescence, quenching and non-quenching extinction of fluorescence and probable mechanism for quenching, characteristic of bypass states, spectra, mirror image of file, its violation and causes of violation delay fluorescence, charge transfer process, structural factors favorable for fluorogenic fluorogeni reagents, fluorescence, immunoassay, and its advantages over radioimmunoassay. Cation favoring fluorescence metal chelate formation, field of applications, merits and demerits of fluorometry, assessment as an ultra trace analysis technique, principal type of reactions used in fluorometric analysis, analytical application, phosphometric low temperature phosphorescence, room temperature phosphorescence, advantages and disadvantages, applications, cumulo- cumulunescence theory, measurement of cumulunescence, mechanism in analytical application. Unit 3, Optical method and flow injection analysis. XRF. Basic principle, instruments, excitation sources, energy dispersive and wavelength dispersive XRF technique, their advantages and disadvantages, metrics, effects and their separation, health hazards and safety applications. Inductivity, Inductively coupled plasma atomic emission spectroscopy, principle, atomization and excitation, ICP, source, instrumentation and applications. Flow injection analysis, introduction, principles, theoretical aspects of FIA, technique, predeterminants of sample impact reactors, components of FIA, apparatus, factors affecting FIA, and application. Unit 4, Food and Cosmetic Analysis. The chemical analysis of food. Importance of food analysis, determination of approximate composition, moisture, fats, protein, fiber, carbohydrate, etc. Quantitative analysis for food quality and safety. Determination of minerals, vitamins, antioxidants, toxins, and preservatives. General ideas of the properties of drugs for their characterization and quantification. Quantitative method of analysis, gravimetry and volumetric analysis. Potentiometry, colorimetry, and amperometry titration. Colorimetric, fluorometric, and polarimetric methods. Analysis of artificial sweeteners in food and coloring agent. Analysis of cosmetic. Composition of cream and lotions. Determination of water, propylene, glycol, non-volatile matters, and ash content. Determination of borates, carbonates, sulfates, phosphates, chlorides, titanium, and zinc oxides. Analysis of phase powder. Estimation of boric acid, magnesium, calcium, zinc, iron, aluminum, and Ba. Analysis of deodorants and antiperspirant. Composition analysis of fats and fatty acids, boric acid, magnesium, calcium, zinc, iron, titanium, aluminum, phenol, hexachlorophenol, methylamine, sulfonates, and urea. Unit 5, Forensic and Fuel Analysis. Fuel, Forensic analysis. Special features of forensic analysis: sampling, sample storage, sample dissolution, classification of poison, lethal dose, significance of LD50 and LC50, general discussion of poisons with special reference to mode of action of cyanide, organophosphate, and snake venom. Estimation of poisonous materials such as lead, mercury, and arsenic in biological samples. Fuel analysis. Solid, liquid, and gaseous fuel. Characteristic of ideal fuel. Ultimates and proximate analysis of coal. Heating value. Grading of coal. Liquid fuel, flash point, aniline point, knocking, anti-knock compounds, octane number, cetane number, and carbon residue. Gaseous fuel produces gas and water gas, determination of calorific value, analysis of fuel gas, numerical problems. Next paper, special paper organic. Next paper is inorganic chemistry, that is material chemistry. Unit 1, glasses, ceramic, and composite material. Glass. Glass's state and its property. Classification. Silicate and non-silicate glasses. Manufacture and processing of glass. Glass's state. Glass formers and glass modifiers. Next, ceramics. Ceramic structure. Mechanical property. High technology. Ceramic and their application. Clays and refractory material. Clays and refractory materials. Classification, structure, and modification of clays, properties and application of clays. Next, refractories, classification, properties and applications. Microscopic composite, composite materials, definition, glass transition temperature, fiber, concrete, and asphalt material, polymer composite, application, ceramic and refractories. Introduction, classification, properties, raw materials, manufacturing and application. Unit 2nd, liquid crystals, mesomorphic behavior, thermotropic liquid crystals, positional order, bond orientation order, pneumatic and schematic mesophase, schematic pneumatic transition cleaning, sorry, clearing, temperature, homeotropic planar, and scleran texture, twisted, pneumatic, chiral, pneumatic, molecular arrangement in schematic A as metic C phases, optical properties of liquid crystals, dielectric susceptibility and dielectric constant, li- lyrotropic phases, and their description of ordering in liquid crystals. Biomaterial, biomineralization, control formation of biological composite, bone, and other mineral tissue, material of construction, applications, general aspects only. Unit 3, Nanochemistry. Introduction. Definition of nanoscale material, different types, different physical and chemical synthetic routes, characterization of nanoscale material by modern instrumental technique, physical and chemical property of nanoscale material, electrical properties, magnetic properties, optical extinction property, unique optical signature of various nanostructure, fluorescence, chemical reactivity, self-assembly of various nanostructure and its importance. Catalytic aspects of nanoscale material. Catalysis using nanoparticles of metals and metal oxides with different sizes and shapes. Useful chemical conversion using nanoparticles. Nanoscale material in emerging technology. Useful properties that can be exploited for applications in the area such as environmental remediation, adsorption, drug delivery, medical imaging, future prospect precautions in using nanoparticles. Nano, nanopores Nanoporous material. Introduction. Zeolite and molecular sieves. Classification. Fundamental properties of zeolites. Qualitative and quantitative determination of surface acidity. Hydrothermal synthesis of zeolite. Factors affecting the zeolite preparation. Modification. Method of characterization and catalytic applications. Catalysis. Basic principle, types, industrial requirements, classification, theory of catalysis, type of homogeneous and heterogeneous catalyst, advantages and disadvantages, thermodynamic and kinetic aspect, essential properties of catalyst, characterization of catalyst, solid state reaction, types, sintering, nucleation, factors influencing the reactivity of solids, precursors to solid state reaction, Tam- Taman and Hedwall mechanism, Wagner diffusion theory of reaction, material transport in solid state reaction, counter diffusion, Kirkendall effect, Hooting mechanism, kinetic model, reactions in powder compact, parabolic rate law, parabolic rate law, Ander rate equation. Unit 5 Fertilizers. Different types of fertilizers. Manufacture of following fertilizers: urea, amino, ammonium nitrate, calcium ammonium nitrate, ammonium phosphate, for polyphosphate, superphosphate compounds, and mixed fertilizers: potassium chloride, potassium sulfate. Coordination polymers: homo and heterocatenated inorganic polymers, polyphosphizins, synthetic roots and bonding features, polymerization of organometallic substitutes, phosphizins, and their applications. Polysilane, sigma bond delocalization in silanes and its implications, synthesis and characterization of polysilanes. Polysiloxane, synthesis, routes via anionic and cationic polymerization, properties and environmental aspects, dendritic macromolecules based on inorganic elements, coordination polymers, polymers based on boron, borazine, polymeric compound of sulfur, polythiols silicate with reference to preparation, properties, structure, bonding, and applications. Natural polymers and reactions yielding coordination polymers, synthesis of coordination polymers. Next paper is Organic Chemistry, that is Applied and Medicinal Chemistry. First part, Unit 1, Polymer, Dyes and Agrochemicals. A. Mechanism of polymerization, study of polyester, polyamide, PVC, polystyrene, polyvinyl acetate, polyvinyl alcohol, polythenes, viscous rayon, synthesis of polyethylene and polypropylene. Synthetic rubber, styrene, butadiene, butyl polyisopropene, polyurethane, vulcanization mechanism, phenol, formaldehyde, resin, stereoregulated polymers, atactic, isotatic, isotactic and syndiotactic polymers, plasticizer, foaming agent, antioxidant for polymers. B part, dyes. General introduction: optical brighteners, thermal sensitivity dyes, dispenses dyes, fibers filling in dyeing, use of carrier in dyeing, use of heat energy in dyeing, study of quinone yellow, cymine dyes, ethyl red, methylene blue, alzerine, cyanamine, cymine, green fluorescein, cosine, erythrocene, rhodomines, and indigo. Agrochemicals. Carbamates, pesticides. Introduction: carbaryl bayon serum, organophosphorus pesticide, malathion monocroptophos dimethoids. Unit 2nd, general aspects of drugs. Historical definition used in drugs, chemistry, pharmacy, pharmacology, pharmacodynamics, pharmacodynamic agent, metabolites and antimetabolites, gram positive and gram negative bacteria, virus, actinomycetes, mutations, chemotherapy, nomenclature of medicinal compound, classification of drugs on basis of their therapeutic action, chemotherapeutic agent, cancer, chemotherapy, synthesis of mechloroethamine, cyclophosphamide, melphans, uracil, mustard, recent development in cancer therapy, for pharmacodynamics agent, mechanism of chemotherapeutic action, biological defense, chemical defense, surface active agents, metabolic antagonism, assay of drugs, chemical assay, biological assay, and immunological assay. Unit 3, Drug Design. Classification of drugs, procedure followed in drug design, concepts of lead compounds and modification concepts of prodrugs and soft drugs, structure activity relationship, factors affecting bioactivity resonance, inductive effects, isosterism, biosterism, spectral consideration, theories of drugs activity, occupancy theory, rate theory, induced theory, quantitative structure activity relationship, history and development of QSAR, concepts of drugs receptor interaction, physiochemical parameter, lipophilicity, partition coefficient, electronic ionization constant, steric Shelton, and surface activity parameter, and redox potential. Pre-Wilson analysis, Hench analysis, LD50, ED50, mathematical derivatives of equations included, ligands-based drug design, diversity-oriented synthesis of drugs design, structure-based drug design, fragments-based drug design, natural product-based discovery, diversity orientation synthesis in drug discovery, virtual screening. Unit 4th, classification of drugs. First, synthesis mode of action, pharmaco- pharmacokinetics, pharmacodynamic data, and secondary metabolism of following drugs. Antibiotics. Introduction, penicillin V and G, streptomycin, chloramphenicol, tetracyclines, antimaterial, chemotherapy of malaria, aminoquinoline, pharmacoin, chloroquine, and sulfons. Antipyretic and allergic, aspirin, salol, phenansic, antipyrin. Anti-inflammatory, ibuprofen, oxyphenylbutazone, diclofenac, indomethacin. Sedas- Sedatives and hypnotics. Barbi- barbiturates, mode of action, diazepam, caffeine, mescaline, hermine. Unit 5th, classification of drugs. Second. Unit 5th, classification of drugs. Second. Synthesis mode of action, pharmacokinetics, pharmacodynamic data, and secondary metabolism of following drugs. Anti tubercular and anti-protic. Etham, ethambutol, isoniazid, dapsone, anesthetic, lidocaine, thiopental, antihistamine, phenobarbital, diphenylhydramine, tranquilizer, diazepam, trimifrazine, cardiovascular, synthesis of di- dilyazim, quinidine, methyl dopa. Next paper, organic chemistry that organic synthesis. Unit 1, application of organometallic in organic synthesis. Organometallic reagents. Organo, lithium, magnesium, mercury, zinc, and copper reagent. Preparation using transmetallation, functionalization, zinc and copper reagent, synthetic application, and Cram rule. Organotin reagent, hydrostenation reactions, and synthetic utility. Organoboron and aluminum reagents, alkyl and aryl derivatives, synthesis and example of applications in CC bond formation reactions. B. Organotransition metal reagents. Metals, iron, Cr, MO, Ni, CO, RH. Carbonyl compounds in organic synthesis. Metals, arene complexes, synthesis and structure. Activations of arene nucleus and side chain. Nucleophilic substitution and addition of arene. Metals, ines, dienes, and dienyl complexes. Metal complexes as protecting groups. Activation towards nucleophilic addition reactions. Synthetic utility. Pi allyl palladium, nickel, and iron complexes, synthesis and their synthetic utility. metal cobalts, alkenes, complexes, protections of triple bond, metal RHIR catalyze CH activation reactions and their synthetic utility. Metallurgines, introduction, synthesis, and chemical reactivity of fluorescence, cobaltines, nickel, nickelosines, copper, and rhodium based carbines and nitrines complexes. Designing Unit 2nd, designing the synthesis based on retrosynthetic analysis. A disconnection approach to the synthesis of organic compounds, different consideration in designing target molecule, concepts of synthesis, FGI, chemoselectivity, radioselectivity, specificity, stereoselectivity, general strategies choosing a disconnection, types of bond disconnection, some of the application of these concepts in designing and the synthesis of common important class of compounds. Ring synthesis, saturated heterocycle synthesis of 3, 4, 5, 6, and 6 membered ring, synthesis of some complexes molecule by retrosynthetic analysis of the following compounds: camphor, reserpine, and vitamin D2. Unit 3, protection and the protection of functional group. Protection and the protection of functional group like hydroxyl, amino, carbonyl, and carboxylic acid groups. Technique employed for this: phase transfer catalysis, quaternary ammonium and phosphonium salt, crown ethers. Their methods of preparation and application in organic synthesis, mechanism of phase transfer reaction, ozone phase transfer catalyst. Unit 4, reagents in organic synthesis. Use of the following reagents in synthesis of functional group transform, transformations such as complex metal hydrates, Gilman reagents, lithium dialkyl cuprate LDA, DCC, trimethyl iodide, tributyl tin hydride, Woodward's and Prevost hydroxylation, DDQ, chloran- chloranyl Peterson synthesis, Becker yeast, periodicity acid, periodids, diazomethane, selenium dioxide, RuO4, IBX, DMP, Heck reaction, Mukayama reactions. Unit 5th, heterocyclic compound. Nomenclature and familiarity with the heterocyclic ring 3 7 member containing up to 3 heteroatoms. Details chemistry of pyrrozole, imidazole, oxazole, thiazole, thiazine, diazine, triazines, pyrimidines, pyrazines, and zipines, oxypines, indoles, benzofurans, quinolines, flavorins, chromones, coumarine, phenithiazine, azitine, azitizine, azitidinase. This is all about the syllabus of MSc second year, same fourth organic chemistry. That is MSc organic chemistry. Thank you for watching my video. Take care.